So, as mentioned, we're recent graduates from UTS. This is our first commission. We essentially started our studio as a way of producing and experimenting as much as possible. So straight out of uni, we got our own CNC equipment, laser and router. And the idea being that we could produce as much as possible. This being our first project, we're asked to basically translate drawings of the CTA building at Martin Place into a model that could be put together easily by the general public without any glue. And I guess the main idea being that we could produce as many prototypes and turn this over within a short amount of time because we had access to our own equipment. These are sort of just a snapshot from one of the drawings.
So what we found so crucial was this idea of the translation of abstraction to a tangible object for people to use. For, I guess, the general public, they could understand the architectural quality behind the CTA building. What we found so prevalent with the way that we worked was we were able to iterate with what we did. And what we did was we changed the 3D model into something that was feasible for everyone to use, which in this case was the flat pack sheet. As you can see, all of the cuttings kind of grouped. So the elements such as structure, circulation, and all that is more or less evident for people to see, that they could put it together. What we found so great about the process is that it's not so much about, trying to find a really fine model or this idea of finding finesse or perfection within something, but rather it's more like we're able to iterate, we're able to change, we're able to not be afraid of making mistakes with the way that we design. And what we see here is this idea of iteration, that we work in such accuracy with the way we try to communicate ideas. So with this model, you can see that, all the joints, all the tabs and all that, they're so fine. You're working within tenths of a millimeter. And in a way, you can kind of see how everything is kind of arranged. This model is kind of broken down, and it works in this like part-to-part relationship. And it's easy for everyone to understand, as opposed to the really abstract 2D drawings that you were seeing beforehand. So you see here this idea of walls, space, circulation, structure. It's all about this idea of assemblage, and it works in the way that a building would be assembled. So again, this idea that there's also an element of presentation, of scale. Everything works together in kind of like a harmonious balance, really. So he's waiting for this. And you can see here as well that we use lots of different techniques as to how we conveyed ideas. So like, for example, stairs, this idea that it's semi-abstract, but yet it's still tangible enough for people to see. Different techniques such as scoring and cutting, engraving even. And it all works together. And that's the finished model, as you can see there. So it has a base, you can like pull it apart. So it works as like a presentation, it works as like an iterative process. That's just, I guess, the genesis of what we came with the project.
So the idea also is that at the last minute we decided to create a presentation model out of plywood, so just to change the material, which you'll see coming up. But the great thing about it is we were able to 3D print it, put it together within 24 hours because of the access to the kind of equipment. So we believe that that's sort of where, offices could be heading, is to be able to produce and turn over from prototype to production within, like 24 hours or much less time. So we established our studio on the pretense that we would have this access to this kind of equipment. And then so the model was accepted really well. Some people found it extremely difficult. Other people put it together in no time at all. But I guess the intention was that they would understand the building a whole lot better, and I suppose that's worked. In the next photo, you'll see someone actually not quite understanding how the core of the building was supposed to be oriented. So they've actually put it together in the wrong way on the left here. But eventually that was corrected, and they started to understand exactly how the building would work or how it's broken down. The next model coming up is the plywood model I was talking about.
What we found so great about this was it was kind of like a social experiment. Some people understood space a lot better than others did. Some people understood the relationships between the different parts. But what was great about it was this idea of communication. We wanted people to actually talk to each other as to how they did it, help each other out. And it created this great dynamic where people just understood the building. And here's the model on top.
Yeah, so this is the one we produced within 24 hours overnight, which we did just because we wanted to try it out and see how it would work. And I guess it worked quite successfully. And to this end, the next project coming up was a competition entry for Thyssen Krupp elevator competition. It was undertaken with our course director, Adrian Lahoud. And so what we were able to do with that was use Rhino plugins in the next model to quickly manipulate the roof structure and the model to produce as many 3D prints as possible to refine the actual form of the roof and the location of the columns. And so then what we did with that was eventually produced a presentation model, which you see here, and we were able to turn that over in, super quickly as well. So the idea being that we could produce as much as possible, refine as much as possible in as little time. And we didn't win the competition, but I think it's a great project anyway. And that's it.